video to show you how easy it is to move from an Excel dataset into plotting it onto Desmos. Okay, so we can just highlight all the data that we want to plot. Command C, that's on my Mac. You might have a different shortcut for copying all the data. And then if you open Desmos graphing, we can literally just in a blank space do Command V, and voila, amazing, right? It pastes them all in X1, Y1. It chooses a suitable scale for you already. How amazing is that? And then you can go and think about what is the shape of the data. Are there any outliers? Maybe those first two look quite out there, right? I mean, the rest look kind of linear-ish. So we might delete these two data points or not, your choice. If you wanted to delete them, you would literally just backspace it. And we could, there you go, so that's the first 2 points. That looks a little bit better, yeah, maybe straight line, maybe a curve, okay? So that's literally just once we've processed our data in Excel. You can see, look, there, here's my raw data that I got from Wikipedia page, and then I played with it to make it into seconds, and I changed the years into years since 1908, and here is my lovely updated table here. So there's all my data points that I wanted to plot on the graph. So I literally just copy and paste. So that's the first thing, how to get a really nice looking graph. The second thing now, of course, is to try and fit the best model. So click in here, I'm going to try and fit a straight line model down the points here. The best thing to do, because everyone's personal laptop keyboard is set up slightly differently, if you open up the Desmos keyboard, you'll have everything there that you want. So now we want to fit a model that links the Y, the output, the times, with the X, the input, the number of years, right? So now look at the data points, Y and X are actually Y1 and X1 here. All right, so we need to use those letters. So we're going to type in Y1, we want to be modeled by. Now the magic little symbol for model is click ABC and then find this little squiggle. Okay, it's got a special name, maybe you can find out what that special name is. And then I'm going to put MX1 plus C or B, and look at that, isn't that beautiful? So we know that the straight line equation that models this data is Y equals M, which is negative 19.6, this should be looking familiar to you, times by X plus C plus 9,282.87. So there's the equation of the line of best fit. And I think that's pretty cool, right? You could take that and then you could maybe do a screenshot of this and paste it into your Word document. I am going to paste that straight into my Word document now, and then I'm going to show you how to tidy up that screenshot so you can include a title and axis and labels for the axes. But one final thing in here, when you talk about how accurate is the model for fitting the data, remember we have this magic R value. This is the correlation coefficient, and R is negative 0.9643. If it was -1, all these points would be on a perfect straight line. So it's not far off a perfect straight line, which is good. And then if you think about the errors, this model tells us that the world record will be something like this when it's actually here. So the difference between these two we call the residual, the error, all right? So after year 13, the model, the line is predicting 9,027.5, and the actual world record you can see is 9,156. So as we go down here, you can see that, you know, there are some very accurate predictions from the line, and some predictions are a little bit too high or maybe a little bit too low down here. If you wanted to see the visual of these residuals, then you could click the plot, and the residual plot is now added to your table. So you can see that the first world record is 9496, okay, here. But our prediction is quite a long way away from it. It's 300, right? So 300 seconds away. So the smaller the number here on the error, the better the prediction. All right, so that's quite handy to have. I hope that will help you.